This video is about day 2 of Pythagorean theorem and its converse. So remember that Pythagorean theorem is c squared equals a squared plus b squared. Remember that c squared has to be your hypotenuse, so it may or may not be the variable depending on the problem. So in number 1, we want to solve for x. So across from the right angle is our hypotenuse, which is 75. So that's going to be our c value. So we would have 75 squared equals x squared plus 72 squared. So 75 squared is 5,625 equals x squared plus 72 squared is 5,184. So to solve for x, we're going to subtract the 5,184 from both sides. And we get 441. To get x by itself, we take the square root. So x is going to be 21. In number 2, we have two triangles put together, so we're going to need to do Pythagorean theorem twice. So first, we're going to use the triangle that's on the right because we have two side lengths. So when I'm doing Pythagorean theorem, if this is my right angle, the hypotenuse would be 26. So we get 26 squared equals x squared plus 10 squared. So we get 676 equals x squared plus 100. We can subtract 100 from both sides and take the square root. So we get x is 24, which is helpful for moving into our second triangle because x is a shared side. So now that we know x, we can do Pythagorean theorem to find y. Y is this time the side that's across from the right angle, so we would have y squared equals 24 squared plus 18 squared. So my calculator, I put all in at once. 24 squared plus 18 squared gets us 900. Take the square root, and y is equal to 30. Number 3. Now, the triangle on the left has two angles that are 50 degrees. So if we have two congruent angles, this is going to be an isosceles triangle, which means these two legs are going to be congruent. So if one was 12, the other side's 12. So now I can take my other triangle, that's a right triangle, and do Pythagorean theorem to solve for x. So I would have x squared, because it's across from the right angle, equals 12 squared plus 5 squared. 12 squared plus 5 squared is 169. Take the square root, so we get x is 13. In number 4, if I have two angles that are 60, this angle is also going to be 60 degrees, so this triangle is an equilateral triangle, which means all of the sides are 41. Now that I know all of the sides are 41 and I know the hypotenuse, I can use this to find my missing side, which is x. So to find that side, I'm going to do Pythagorean theorem with 41 by itself. So we have 41 squared equals x squared plus 40 squared. 1,681 is equal to x squared plus 1,600. We can subtract 1,600 from both sides. So 81 equals x squared. Take the square root, so x is 9. Given the sides of the triangle, classify it by its angles, obtuse, acute, or right. So remember when we're doing this that we are going to use our relationship with c squared and a and b. So if c squared is equal to a squared plus b squared, it's going to be a right triangle. If c squared is greater than a squared plus b squared, it's going to be an obtuse triangle. And if c squared is less than a squared plus b squared, it's going to be an acute triangle. Remember when we're doing these problems that the c value is going to be the largest side. So in number 5, 19 is our largest side, so we're going to have 19 squared, leave a blank, 12 squared plus 14 squared. So we get 19 squared is 361, and 12 squared plus 14 squared is 340. So because 361 is greater than, this would be an obtuse triangle. Number 6, the largest side is 61, so that's going to go by itself. So we would have 61 squared, leave a blank, 11 squared plus 60 squared. So 61 squared is 3,721. And 11 squared plus 60 squared is also 3,721. So because these are equal, this would be a right triangle. Now, we've done these problems a couple of different times. We're now going to classify it, though, by sides and angles. Before, we were just doing sides. So the first thing we have to do is we have to plot our points. So remember that whatever comes first is your x, whatever comes second is your y. So D is at 2, 5. E is at 2, -7. And F is at 10, -1. So I need to find the 3 side lengths of this triangle. So if it's a vertical or a horizontal line, we can just count. So DE is really easy to find. We can just count from D to E. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we know that DE has a length of 12. Now, the other two sides, it's not as easy because they are diagonal. So we're going to have to use the distance formula. So remember that the distance formula is x2 minus x1 squared plus y2 minus y1 squared. So the first side I'm going to find is df. So square root, I'm going to subtract my x coordinates. So f is 10 for an x coordinate and e is 2 for the x coordinate. So 10 minus 2 squared plus the y coordinates. Oh, we're going to do ef first. Are going to be -1 and -7. So -1 minus -7 squared. So 10 minus 2 is 8, squared is 64. -1 minus -7 is 6, squared is 36. Remember, when we square the number, it doesn't matter if it was negative or positive, it's always going to become positive, which is the square root of 100, which is 10. So far we know this side is 12, we know this side is 10. Now we're going to find the length of DF. So DF is 10 minus 2 again for the x's, plus -1 minus 5 squared for the y's. 10 minus 2 squared is 64. -1 minus 5 squared is 36. So we get the square root of 100, which is 10. So because we have two of our sides that are the same length, this is going to be an isosceles triangle. Then, to classify by angles, we're going to use that Pythagorean theorem part we were doing, so the sides are 10, 10, and 12. So 12 is the largest, so it's going to be by itself. 12 squared, leave a blank. 10 squared plus 10 squared. So 12 squared is 144. 10 squared plus 10 squared is 200. So because 144 is less than 200, that means by the angles, it's going to be acute.